Question 161. A recent audit revealed that a new network was created in your GCP project. In this network, a GCE instance has an SSH port open to the world. You want to discover this network's origin. What should you do? A. Search for Create VM entry in the Stackdriver alerting console. B. Navigate to the activity page in the Home section. Set category to Data Access and search for Create VM entry. C. In the Logging section of the console, specify GCE network as the logging section. Search for the Create Insert entry. D. Connect the GCE instance using project SSH keys. Identify previous logins in system logs, and match these with the project owner's list. The best approach would be C. In the Logging section of the console, specify GCE network as the logging section. Search for the Create Insert entry. Explanation. When you need to track the creation of a network or firewall rule, the logging section is indeed the most appropriate place to look for this kind of activity. GCP's audit logs, which include admin activity logs, will capture resource creation events, such as the creation of networks or firewall rules. The Create Insert entry will specifically capture actions related to the creation of resources, including network resources. By filtering the logs under GCE network and searching for Create Insert, you can pinpoint when the network was created and which user performed the action. This aligns better with the task of identifying the origin of a network that has an open SSH port. Analysis of other options. A. Search for Create VM entry in the Stackdriver alerting console. This option focuses on alerts, but alerts are typically for ongoing monitoring, not detailed auditing. It's not the right tool for tracking the origin of resource creation. B. Navigate to the activity page in the Home section. Set category to Data Access and search for Create VM entry. As you correctly pointed out, creating networks and firewall rules are admin activities, not data access activities. The activity page will not capture these as data access events. D. Connect the GCE instance using project SSH keys. Identify previous logins in system logs, and match these with the project owner's list. This option focuses on accessing the instance and reviewing past logins, but it doesn't help with auditing the creation of the network or firewall rule. It's more about understanding who accessed the instance after it was created, not who created the network. Conclusion. Option C is now the most appropriate choice. By using GCP logging and filtering for Create Insert under GCE network, you'll be able to find the relevant admin activity logs that show who created the network and firewall rule, addressing the issue of identifying the origin of the network with the open SSH port. Question 162. You want to make a copy of a production Linux virtual machine in the US Central region. You want to manage and replace the copy easily if there are changes on the production virtual machine. You will deploy the copy as a new instance in a different project in the US East region. What steps must you take? A. Use the Linux dd and netcat commands to copy and stream the root disk contents to a new virtual machine instance in the US East region. B. Create a snapshot of the root disk and select the snapshot as the root disk when you create a new virtual machine instance in the US East region. C. Create an image file from the root disk with Linux dd command. Create a new virtual machine instance in the US East region. D. Create a snapshot of the root disk. Create an image file in Google Cloud Storage from the snapshot, and create a new virtual machine instance in the US East region using the image file the root disk. Explanation. The process in option D involves creating a snapshot of the root disk from the existing production VM, then creating an image from that snapshot stored in Google Cloud Storage. This method is appropriate because it ensures the snapshot is preserved and accessible as an image, which can then be used to launch a new VM instance in a different region, like US East. This approach is necessary for several reasons. Snapshots are used to capture the state of a disk but are not directly usable across projects or regions as a bootable disk. By converting the snapshot into an image stored in Google Cloud Storage, the image can be used to create new instances anywhere, including in a different project and region. This method ensures that the newly created VM will use the snapshot as its root disk, effectively replicating the original VM in a new environment. Detailed steps. 1. Create a snapshot of the root disk of the production VM. 2. Create an image from the snapshot and store it in Google Cloud Storage. 3. In the US East region, create a new VM instance using the image stored in cloud storage as the root disk. This method ensures that the copy of the production VM is easily managed and that future updates or changes to the original VM can be reflected by simply updating the image and redeploying the new VM. Analysis of other options. A. Use the Linux dd and netcat commands. This method involves manually copying the contents of the root disk to a new VM, which is not a recommended or scalable solution in GCP. It adds unnecessary complexity and relies on manual processes that are error-prone. B. Create a snapshot and select the snapshot as the root disk. While snapshots are useful, they do not directly translate to a bootable disk in another project or region. The extra step of creating an image, as described in option D, is required to make the snapshot bootable in a new region. C. Create an image from the root disk with Linux dd. This option again involves manual processes, example using Linux dd, which are not native to GCP's best practices. Images in GCP should be created directly from the snapshot or disk, without needing to rely on external tools like dd. Conclusion. Option D is the correct choice because it leverages Google Cloud's native features, snapshots and images, to ensure the VM is easily replicable and manageable across projects and regions, following best practices for VM creation in GCP. Question 163. Your company runs several databases on a single MySQL instance. They need to take backups of a specific database at regular intervals. The backup activity needs to complete as quickly as possible and cannot be allowed to impact disk performance. How should you configure the storage? A. Configure a cron job to use the gcloud tool to take regular backups using persistent disk snapshots. B. Mount a local SSD volume as the backup location. After the backup is complete, use Xutil to move the backup to Google Cloud Storage. C. Use GCSFIce to mount a Google Cloud Storage bucket as a volume directly on the instance and write backups to the mounted location using MySQL. D. Mount additional persistent disk volumes onto each virtual machine, VM, instance in a RAID 10 array and use LVM to create snapshots to send to cloud storage. The best approach is B. Mount a local SSD volume as the backup location. After the backup is complete, use Xutil to move the backup to Google Cloud Storage. Explanation. Using local SSD for backup storage offers several advantages for this scenario. Local SSDs are designed for high-performance, low-latency workloads, making them ideal for operations that require fast backups without impacting the disk performance of your production databases. Here's why this approach is effective. Local SSDs provide high throughput and low latency, which ensures that the backup process completes quickly and doesn't burden the system's main disk. After the backup is completed on the local SSD, you can use Xutil to efficiently transfer the backup to Google Cloud Storage. This offloads the backup data from the local SSD to persistent, scalable cloud storage, ensuring data durability and easy retrieval without affecting the performance of the MySQL instance. This approach ensures that the backup process is fast, efficient, and isolated from the main disk, minimizing impact on disk performance. Analysis of other options. A. Configure a cron job to use the gcloud tool to take regular backups using persistent disk snapshots. Persistent disk snapshots can be used for backups, but they are typically used for full disk backups, which may not be as fast as other methods. Snapshots also have the potential to affect disk performance, especially when taken on a running system, and may not provide the level of control and speed needed for frequent database backups. C. Use GCSFUs to mount a Google Cloud Storage bucket as a volume directly on the instance and write backups to the mounted location using MySQL. While GCSFUs can mount a cloud storage bucket as a volume, it introduces network latency and does not provide the same performance characteristics as local SSDs. Backup operations directly to cloud storage via GCSFUs could be slower and may impact performance during the backup process due to I/O bottlenecks. D. Mount additional persistent disk volumes onto each virtual machine (VM) instance in a RAID 10 array and use LVM to create snapshots to send to cloud storage. This approach introduces significant complexity and overhead with RAID and LVM management. While RAID 10 provides redundancy, it adds unnecessary complexity to the backup process. Moreover, creating snapshots of LVM volumes could impact system performance, especially during backup operations, making it less ideal for a scenario where minimal disk impact is critical. Conclusion: Option B is the best approach. Using a local SSD for backup storage ensures that the backup process is fast and isolated from the main system disk, minimizing performance impact. Moving the backup to cloud storage using XUTIL ensures data durability and scalability. Question 164. You are helping the QA team to roll out a new load testing tool to test the scalability of your primary cloud services that run on Google Compute Engine with Cloud Bigtable. Which 3 requirements should they include? Choose 3. A. Ensure that the load tests validate the performance of Cloud Bigtable. B. Create a separate Google Cloud project to use for the load testing environment. C. Schedule the load testing tool to regularly run against the production environment. D. Ensure all third-party systems your services use is capable of handling high load. E. Instrument the production services to record every transaction for replay by the load testing tool. F. Instrument the load testing tool and the target services with detailed logging and metrics collection. Let's reassess the question and carefully examine the best approach. Correct solution. The 3 correct requirements to include are A, B, and F. Explanation. A. Ensure that the load tests validate the performance of Cloud Bigtable. Since your environment includes Cloud Bigtable as a primary service, you must include it in the load testing process to verify its performance. Cloud Bigtable is often a critical component for handling large-scale data, so validating its scalability and performance under load is essential. B. Create a separate Google Cloud project to use for the load testing environment. Isolating the load testing in a separate project is a best practice. It prevents the load testing activities from affecting the production environment, allows you to manage costs more effectively, and ensures that any issues arising during testing won't impact your production services. It also helps avoid any confusion or mix-up between production and test resources. F. Instrument the load testing tool and the target services with detailed logging and metrics collection. Detailed logging and metrics collection are critical for analyzing the results of the load test. It will provide you with insights into how the services behave under load, highlight any bottlenecks, and help you make data-driven decisions. Instrumentation helps ensure that you can effectively monitor the performance of the services, analyze resource utilization, and detect any failures or issues during the test. Analysis of other options. C. Schedule the load testing tool to regularly run against the production environment. Running load tests regularly on the production environment can be dangerous, as it may affect service availability and performance. It's generally safer to run load tests in isolated environments, such as a separate testing or staging environment. Regular tests on production should only be considered in controlled scenarios, and not as a first option. D. Ensure all third-party systems your services use are capable of handling high load. While third-party systems might be critical, the question specifically asks for load testing the cloud services, including Compute Engine and Cloud Bigtable. While it's important to consider third-party systems, it is not the primary focus here, and ensuring the third-party systems are capable of handling high load is outside the scope of the immediate load testing requirement. E. Instrument the production services to record every transaction for replay by the load testing tool. Recording every transaction is not always practical or necessary for effective load testing. Instead, load tests typically simulate traffic or user behavior that closely matches real-world usage patterns. Recording every transaction could be inefficient and would likely add unnecessary complexity to the load testing process. Question 165. Your customer is moving their corporate applications to Google Cloud Platform. The security team wants detailed visibility of all projects in the organization. You provision the Google Cloud Resource Manager and set up yourself as the org admin. What Google Cloud Identity and Access Management, Cloud IAM, roles should you give to the security team? A. Org Viewer, Project Owner. B. Org Viewer, Project Viewer. C. Org Admin, Project Browser. D. Project Owner, Network Admin. The correct answer is B. Org Viewer, Project Viewer. Explanation. To meet the security team's need for detailed visibility across all projects in the organization, the following roles are appropriate. 1. Org Viewer. This role provides read-only access to the organization resources, allowing the security team to view all resources and settings at the organizational level without the ability to make changes. This role gives visibility into the organization itself, including project-level information. 2. Project Viewer. This role grants read-only access at the project level, allowing the security team to see the resources within each project, such as VMs, storage, and databases. It ensures the team can monitor and inspect resources but not modify them. Analysis of other options. A. Org Viewer, Project Owner. The Project Owner role provides full administrative permissions within the project, which is not necessary for a security team seeking visibility only. They do not need to be able to manage project resources or settings, read-only access is sufficient. C. Org Admin, Project Browser. The Org Admin role grants full administrative access to the organization and its resources, which would be excessive for the security team. The Project Browser role doesn't exist in Cloud IAM. Project Viewer would be the correct role for viewing project resources. D. Project Owner, Network Admin. Both Project Owner and Network Admin grant more permissions than needed for the security team's goal of visibility. These roles are focused on management and configuration, not just viewing resources. Conclusion. To provide detailed visibility without granting excessive permissions, Org Viewer and Project Viewer are the correct roles. These roles ensure that the security team can view all organizational and project resources, enabling them to monitor and audit the environment effectively. Question 166. Your company places a high value on being responsive and meeting customer needs quickly. Their primary business objectives are release speed and agility. You want to reduce the chance of security errors being accidentally introduced. Which two actions can you take? Choose two. A. Ensure every code check-in is peer-reviewed by a security SME. B. Use source code security analyzers as part of the CI/CD pipeline. C. Ensure you have stubs to unit test all interfaces between components. D. Enable code signing and a trusted binary repository integrated with your CI/CD pipeline. E. Run a vulnerability security scanner as part of your continuous integration continuous delivery CI/CD pipeline. The correct two actions to take are B. Use source code security analyzers as part of the CI/CD pipeline and E. Run a vulnerability security scanner as part of your CI/CD pipeline. Explanation. B. Use source code security analyzers as part of the CI/CD pipeline. Integrating source code security analyzers in the CI/CD pipeline allows for early detection of security vulnerabilities in the code base before it progresses through the deployment pipeline. This proactive approach minimizes the chance of security errors being introduced and caught later in the process. Security analysis tools can automatically scan for common vulnerabilities and weaknesses, ensuring that developers are aware of potential issues before they go live. E. Run a vulnerability security scanner as part of your continuous integration continuous delivery CI/CD pipeline. Running a vulnerability security scanner during the CI/CD process helps identify security issues, such as known vulnerabilities in libraries, dependencies, or runtime configurations, early in the deployment pipeline. This reduces the risk of vulnerabilities making it to production, ensuring security is maintained throughout the development process. Analysis of other options. A. Ensure every code check-in is peer-reviewed by a security SME. While peer reviews are important, requiring a security subject matter expert, SME, for every code checking can slow down the development process, especially in fast-paced environments that prioritize release speed and agility. Security analysis tools in the CI/CD pipeline can automate much of this process, catching potential issues before code is merged or deployed. C. Ensure you have stubs to unit test all interfaces between components. Unit testing and creating stubs for interfaces are good practices, but they focus more on functional correctness rather than security. They don't directly address the goal of reducing security errors. While important, they are not as directly impactful for preventing security vulnerabilities as automated security scans during the CI/CD process. D. Enable code signing and a trusted binary repository integrated with your CI/CD pipeline. Code signing and using a trusted binary repository are best practices for ensuring the integrity of deployed code, but they do not specifically reduce the chance of introducing security errors during development. These practices are more related to preventing tampering or unauthorized code execution, but they do not address the underlying security flaws in the code itself. Conclusion. To reduce the chance of security errors being accidentally introduced while maintaining agility, the best options are B and E, as they integrate security into the development process with minimal friction and maximum effectiveness. Question 167. You want to enable your running Google Kubernetes Engine cluster to scale as demand for your application changes. What should you do? A. Add additional nodes to your Kubernetes Engine cluster using the following command: gcloud container clusters resize cluster_name euro, size 10. B. Add a tag to the instances in the cluster with the following command: gcloud compute instances at tags instance, tags enable autoscaling max nodes 10. C. Update the existing Kubernetes Engine cluster with the following command: gcloud alpha container clusters update my cluster, enable autoscaling, min nodes is equal to 1, max nodes is equal to 10. D. Create a new Kubernetes Engine cluster with the following command: gcloud alpha container clusters create my cluster, enable autoscaling, min nodes is equal to 1, max nodes is equal to 10 and redeploy your application. The correct answer is C. Update the existing Kubernetes Engine cluster with the following command: gcloud alpha container clusters update my cluster, enable autoscaling, min nodes is equal to 1, max nodes is equal to 10. Explanation. 1. C. Update the existing Kubernetes Engine cluster. To enable autoscaling for an existing cluster, you need to update it with the enable autoscaling flag. The command also allows you to specify the minimum and maximum number of nodes for the node pool, ensuring that the cluster scales based on application demand. This approach is ideal because it applies the changes to your running cluster without needing to create a new one, thereby minimizing disruption. Analysis of other options. A. Add additional nodes using gcloud container clusters resize. This command manually resizes the cluster to a fixed number of nodes. It does not enable autoscaling, so the cluster will not dynamically adjust based on workload demands. B. Add a tag to instances with gcloud compute instances at tags. Adding tags to instances does not enable autoscaling. Tags are used for setting up firewall rules or applying metadata but are unrelated to Kubernetes Engine autoscaling. D. Create a new Kubernetes Engine cluster. While this command correctly enables autoscaling for a new cluster, it requires creating and deploying a new cluster. This is unnecessary if you already have a running cluster that you want to scale. It introduces downtime and operational overhead by requiring application redeployment. Conclusion. To enable autoscaling on a running Google Kubernetes Engine cluster, the best approach is to update the existing cluster using the command in C, as it directly enables the autoscaling feature without disrupting the current setup. Question 168. Your marketing department wants to send out a promotional email campaign. The development team wants to minimize direct operation management. They project a wide range of possible customer responses, from 100 to 500,000 click-through per day. The link leads to a simple website that explains the promotion and collects user information and preferences. Which infrastructure should you recommend? Choose 2. A. Use Google App Engine to serve the website and Google Cloud Data Store to store user data. B. Use a Google Container Engine cluster to serve the website and store data to persistent disk. C. Use a managed instance group to serve the website and Google Cloud Bigtable to store user data. D. Use a single compute engine virtual machine, VM, to host a web server, backend by Google Cloud SQL. The correct options are A. Use Google App Engine to serve the website and Google Cloud Data Store to store user data, and C. Use a managed instance group to serve the website and Google Cloud Bigtable to store user data. Explanation. 1a. Use Google App Engine to serve the website and Google Cloud Data Store to store user data. App Engine is serverless and automatically scales to handle varying traffic loads, making it ideal for the projected range of 100 to 500,000 click-throughs per day. Cloud Data Store is a fully managed NoSQL database that scales seamlessly and is well suited for storing user information and preferences for a marketing campaign. 2c. Use a managed instance group to serve the website and Google Cloud Bigtable to store user data. A managed instance group, MIG, with autoscaling provides a robust solution for hosting a website with varying traffic. The MIG automatically adds or removes instances to meet traffic demand. Google Cloud Bigtable is optimized for high-throughput workloads and large-scale, structured data storage, making it suitable for storing data at scale for a high number of responses. Analysis of other options. B. Use a Google Container Engine cluster, now GKE. While GKE can scale and handle large traffic, it requires more operational overhead for cluster management, which does not align with the development team's desire to minimize direct operations. D. Use a single compute engine VM with Cloud SQL. A single VM is not ideal for handling unpredictable and potentially large-scale traffic, as it does not provide scalability. This setup would be overwhelmed by high traffic and would not meet the needs of up to 500,000 daily click-throughs. Conclusion. For minimal operational overhead and scalable infrastructure, A provides a serverless approach with App Engine and Cloud Data Store, while C offers a scalable alternative with managed instance groups and Bigtable. These solutions ensure responsiveness and reliability for the promotional campaign. Question 169. Your company just finished a rapid lift and shift to Google Compute Engine for your compute needs. You have another 9 months to design and deploy a more cloud-native solution. Specifically, you want a system that is NoOPS and auto-scaling. Which two compute products should you choose? Choose 2. A. Compute Engine with containers. B. Google Kubernetes Engine with containers. C. Google App Engine Standard Environment. D. Compute Engine with custom instance types. E. Compute Engine with managed instance groups. The correct options are B. Google Kubernetes Engine with containers and C. Google App Engine Standard Environment. Explanation. B. Google Kubernetes Engine with containers. GKE is a managed Kubernetes service that offers autoscaling and supports containerized workloads. It reduces operational overhead by managing cluster resources and scaling workloads based on demand. It aligns with the need for a NoOPS and autoscaling solution while providing flexibility for modernizing your applications. See Google App Engine Standard Environment. App Engine Standard is a fully managed, serverless platform designed for autoscaling and NoOPS deployment. It handles infrastructure management, scaling, and maintenance automatically, making it ideal for a NoOPS strategy. It is particularly suited for web applications and APIs. Analysis of other options. A. Compute Engine with containers. While Compute Engine can run containers, it requires you to manage the infrastructure, which does not meet the NoOPS requirement. It also lacks native autoscaling unless paired with additional configurations, such as managed instance groups. D. Compute Engine with custom instance types. Compute Engine with custom instance types allows you to optimize resource allocation but does not inherently offer autoscaling or a NoOPS environment. E. Compute engine with managed instance groups. Managed instance groups provide autoscaling but still require some level of operational management, which does not fully align with the NoOPS requirement. Conclusion. For a truly NoOPS and autoscaling solution, B. GKE provides flexibility for containerized workloads, and C. App Engine standard environment offers a serverless approach with minimal management. These options are best suited for transitioning to a cloud-native architecture. Question 170. One of your primary business objectives is being able to trust the data stored in your application. You want to log all changes to the application data. How can you design your logging system to verify authenticity of your logs? A. Write the log concurrently in the cloud and on premises. B. Use a SQL database and limit who can modify the log table. C. Digitally sign each timestamp and log entry and store the signature. D. Create a JSON dump of each log entry and store it in Google Cloud Storage. The correct answer is C. Digitally sign each timestamp and log entry and store the signature. Explanation. 1. Why C is correct? Digital signatures ensure the integrity and authenticity of logs by allowing verification that the data has not been tampered with. By signing each log entry and its timestamp, any subsequent alteration of the log will invalidate the signature, providing a reliable mechanism to detect tampering. This method aligns with the objective of trusting the stored data, as the signature acts as proof of authenticity. 2. Analysis of other options. A. Write the log concurrently in the cloud and on premises. Storing logs in multiple locations does not inherently ensure their authenticity or integrity. Without additional mechanisms like signatures or encryption, this approach does not verify the trustworthiness of the logs. B. Use a SQL database and limit who can modify the log table. Limiting access reduces the risk of unauthorized modifications but does not prevent potential tampering by authorized users or accidental data corruption. This approach does not provide cryptographic proof of authenticity. D. Create a JSON dump of each log entry and store it in Google Cloud Storage. Storing logs in Google Cloud Storage ensures durability but does not provide a mechanism for verifying that the logs have not been altered. This approach lacks cryptographic integrity checks. Conclusion. The most effective way to ensure the authenticity and trustworthiness of logs is to digitally sign each log entry and timestamp. This provides cryptographic evidence that the logs have not been tampered with, meeting the business objective of trusting the stored data.